This example comes out of section 7.1, Characteristics of Exponential Functions. So in this example, the first thing we're asked is what equation in the form y equals c to the x can be used to describe the graph shown. So we're looking for an exponential function that has to look like this. It does go through the point 0, 1, but that's actually the one point that doesn't really help me, because clearly c to the 0 will equal 1, no matter what c equals. It doesn't really help me solve for c. But either one of these other 2 points would allow me to do the question, and the easiest one probably to take is the fact that c to the 1 has to equal 6, which just tells me that c equals 6. So this graph that we have drawn here is y equals 6 to the x. You can check with the other point to see does c to the 2 equal 36, and the fact is that 6 squared equals 36, so you can use that point to confirm. If you graph this on your calculator, y equals 6 to the x, you'll get a graph that looks just like that. So let's do a second example of this. This one, the question is still the same. What equation in the form y equals c to the x can be used to describe the graph shown? But our graph is a little different, and intentionally I've just given you a couple of points. In fact, I wouldn't even need to give you both of these, probably. But you have 0, 1, which again, we know that if this is in the form y equals c to the x, that c to the 0 should equal 1. Well, that's true no matter what c is. So it doesn't help me solve for the value of the space. But this other point does. C to the negative 2 has to equal 25. Now how you decide to solve that depends on how good you are, I suppose, with your exponent rules. So c to the negative 2 is the same thing as saying 1 over c squared. That needs to equal 25. You could cross multiply and say 1 over 25 needs to equal c squared. So c is going to be the square root of that, which is plus or minus a fifth. But we've said that for our exponential functions we don't deal with negative bases, so c is 1/5. This graph is the graph of y equals 1 over 5 to the exponent x. You can use your graphing calculator to confirm, and it should draw you a curve that decreases as you go to the right and passes through each of the 2 points as given in that question.